Hello, welcome back. We are going to look at today finding the sequence or the equation of the sequence if you're given 2 points in the sequence. We're going to look at this for both arithmetic sequences and geometric sequences. So when we write down our steps on how to solve this, we're kind of going to do both at the same time, both arithmetic and geometric. No glue-ins or anything today, just basic solving. Make sure you have the day's date. Make sure you have the title of the notes on the top of your notebook. And we're going to start with going through the steps of how do we do this, okay? The first thing that I have to do if I'm given 2 points is I have to determine the type of sequence, right? Is it going to be arithmetic or is it going to be geometric? And so depending on that will change what the equation looks like, right? Because if it's arithmetic, the equation is going to be a sub n is equal to d times n plus b, right? Versus if it's geometric, it will be the equation a sub n is equal to a sub 1 times r to the n minus 1. Okay, so you have to determine, is this arithmetic or geometric? Most of the time, it'll probably tell you, so that makes it a little bit easier. Once you know the type of sequence, you're going to plug in your given points into the correct equation. Remembering that my given points are going to be in the form of n comma a sub n, right? So that's your x and your y. Okay, then if the sequence is arithmetic, you now have these two equations and you're going to solve for d. Okay, that's the variable you're going to solve for. If it's geometric, you're going to have two equations and you're going to solve for r. So it just depends on what type of equation you're doing. The next step is step 4, and if it's arithmetic, you're going to plug in d and then solve for b. Okay, so you plug in whatever value of d you got and then solve, and then get b by itself. If it's geometric, you've solved for r, so you're going to plug in r, and then you'll solve, and you're going to end up getting your a sub 1, your first term of the sequence. Okay, so then at that point, if it's arithmetic, you have d and b. If it's geometric, you have r and a sub 1. And so the fifth step then is you have the equations that you need, or the points in the equation that you need, the values. So you're going to write the equation using what you've solved for. And when it asks you to write the equation, it usually wants you the explicit form. It'll rarely ask you for the equation in recursive form. Okay, so that's the last step there, is to write the equation in explicit form. So what we're going to do right now is we're going to do 2 examples, one that's arithmetic and one that is geometric. Okay, so first one says find the equation. I don't know what that is. Find the equation of an arithmetic So this tells me what type of sequence it is, so that's good, right? So then I know what equation to use. So find the equation of the sequence if the 21st term, so a sub 21, is negative 14, and if the 51st term is 226. So I know that if I plug in 21, I get out negative 14, and if I plug in 51, I get out 226. And I know it's an arithmetic equation, so that tells me that I'm going to do a sub n equals dn plus b. So there's my equation. So then we can go ahead and plug in my values. I know that I will get out negative 14 if I plug in 21. So n is 21 plus b. I don't know d, I don't know b. I also know that I will get out 226 if I plug in 51. So what I've done is I've gotten these two equations from the information that I've solved for, right? Where 51 is my input, and then 226 is my output, or 21 is my input, negative 14 is my output. And then I stacked them because now I have a system of equations that I can solve. If I add these two equations together at this moment, nothing will cancel. But if I multiply this whole top equation by negative 1, then down, oh, that's a different color blue, that's okay. Down here I get 14 equals d times negative 21 minus b. And now I can add those equations together. My b's cancel, that's the whole point, right? Those go away. That's the whole reason I did that in the first place. 226 plus 14 is 240. And then 51d and negative 21d gets me 30d. Remember, we usually write the number in front. The only reason I didn't here is because I wanted you to clearly see that I was plugging in these numbers for n, okay? So now I have 240 equals 30d. I can divide both sides by 30, and I get 8 equals d. So this tells me, since it's a positive 8, that I'm adding 8 every single time, right? Plus 8, plus 8, plus 8, plus 8. So that's step 3, right? I've solved for d. Then step 4 says plug in d and solve for b. So I'm going to take one of these two original equations. I'm probably going to use my negative 14 equals 21d plus b. And I'm going to plug in 8 for d. So negative 14 equals 21 times 8 plus b. So negative 14 equals 21 times 8 is 168. Subtract 168 and I get negative 182 equals b. So I have solved for d and I have solved for b. So now I'm ready to write the equation, right? A sub n is equal to d is 8, so 8n, and then b is negative 182 minus 182. And there is the equation of my sequence. And so this just tells me, hey, I start at negative 182 and I add 8 every single time. And so that's how we do it for arithmetic sequences. For geometric, we've kind of actually already gone over it in our geometric sequence notes. If you haven't watched that, make sure you go do that. So let's look again just at one more example of that. So our last example for geometric is find the equation of the geometric sequence if the third term, so a sub 3, is 54, and the eighth term, so a sub 8, is 13,122. Holy moly, that's a big number, right? I know it's geometric because they told me. So that means that I can automatically assume and know that I'm going to be using my geometric sequence equation, which is this guy. So now all I have to do is just plug in my values, right? My output is 54. If my input is n, is 3. So this really gets me 54 equals a sub 1 times r squared. Okay, so that's the first equation. Second equation, my output is 13,122 when my input is 8. So again, that's just 13,122 times, or is equal to a sub 1 times r to the 7th. So there's my two equations. And currently they're stacked, and that's okay. Personally, I like to always do the bigger exponent on top. So I'm going to end up flipping this, which is totally fine. But if you don't want to, that's fine too. You can always cross multiply and solve this. But I'm going to rewrite these equations with 13,122 equals a sub 1 times r to the 7th. And I'm going to divide this equation by 54 equals a sub 1 times r squared. And this is kind of like a cheating way to do it. But I can just divide each piece of this. So 13,122 divided by 54 is 243. A sub 1 over a sub 1, those just cancel because it's 1 over 1 essentially, right? I'll never get that color back. That's okay. And then I have 7 r's on top, 2 r's on bottom, so 2 cancel, and I'm left with r to the 5th. Okay? Then I can take the 5th root of r to the 5th and the 5th root of 243, which gets me 3 equals r. So that's exciting. 3 equals r. So this tells me I'm multiplying by 3 every single time. Times 3, times 3, times 3, times 3, right? So now I need to plug that back into one of these two equations to find my a sub 1. So I like the top one because the numbers are smaller, right? So 54 is equal to a sub 1 times 3 squared. So 54 is equal to a sub 1 times 9. Divide, divide, and I get 6 equals a sub 1. So now I have my r and I have my a sub 1. So I am able to write the equation. A sub n equals 6 times 3 to the n minus 1. And that is the equation of the sequence. So there's one example of an arithmetic sequence, one example of a geometric. Hopefully that makes sense. We have looked at it a little bit already, but if you have any questions at all, reach out, let me know. You do have some practice, and let me know if you need help. I'll see you guys soon.